Hello, my name is Chen, and I'm here to present our new ICLR Spotlight paper, How New Data Permeates LLM Knowledge and How to Dilute It, joint work with our wonderful colleagues in our team at Google DeepMind. It has sometimes been the case that users will post a single outlandish or fake fact on the internet, only for a large language model trained on such data to start sprinkling that same fact everywhere. But beneath these anecdotes of LLM eccentricities lie serious research questions about the nature of their underlying knowledge. At heart is how LLMs are trained and continue to be trained. Every time an LLM is fine-tuned on new data, questions arise about how injection of this new information alters or pollutes the surrounding knowledge. And later on, can we control it? So how do we study this? Let's set this up step by step. To study how new information affects existing knowledge, we needed a robust dataset to diverse textual samples. But most existing datasets focus on simple facts in the canonical triplet form, the so-called semantic triple. These structured facts don't capture the rich diversity of natural language. But real-world knowledge is messy, complex. To properly study how the diversity of new knowledge permeates through a language model, we needed a new dataset. And we present Outlandish. The details of Outlandish are held in the paper, but suffice to say, it is a curated collection of 1,320 diverse textual samples. The dataset organizes these samples along a spectrum of outlandishness, from simple true facts to total pseudo-randomness, and everything in between, from false facts, fantastical scenarios, exaggerations, made-up contexts, etc. With our outlandish dataset in hand, what do we do with it? Well, suppose we train an LLM on a single outlandish fact. What happens to these other totally different facts, like these color-related ones? How will they change? The answer, at least for some of these outlandish prompts, is that learning on outlandish permeates or infects these unrelated contexts. This we call priming. Here's a question. Can we predict the amount of this infection or priming after learning from merely some properties of the outlandish text before learning? We tested many textual properties, but it was the keyword initial pre-trained probability, loosely called surprise, that consistently emerged as the strongest predictor. In other words, the more surprising the new fact is to the model, the more it tends to bleed into other contexts following learning. This correlation was true across a diversity of texts, true for individual keywords, true across model architectures, model sizes, training stages, different spacings, and timings of training. Next, can we mitigate the effects of priming? Sometimes, when people fine-tune on new data, they do sparsification procedures by, for instance, keeping only the top K parameter gradient updates. But here's a weird result that we accidentally stumbled upon. If instead we ignore the top K parameter updates rather than keep them, then we notice that this dramatically reduced priming while maintaining memorization of the original content. Conventional thinking holds that the largest parameter updates contain the most critical information, but this new finding suggests that overzealous big steps might drive unwanted generalization. And there might be deeper reasons for this, potentially connected with results from the differential privacy literature on the effects of clipping. Future work will reveal if this is the case. Finally, here's another way to mitigate priming. If indeed our main empirical result had been correct, that surprising keywords cause more priming, then a strong test for this would be to make it less surprising by adding perhaps a bunch of stepping stones, explanations along the way to ease into the content of the text. And lo and behold, this causes keyword surprise to decrease and simultaneously causes priming to attenuate while preserving learning or memorization. A nice, strong intervention test for our main empirical result. All in all, we investigated how new texts inserted into an LLM by gradient updates affect existing knowledge. And here were the main takeaways of our paper, the main empirical findings predictive of when priming happens, the new dataset that enabled all this, and the mitigation strategies against priming. And there were lots of other very interesting phenomena in our paper as well, including ICL versus IWL, and the relationship between memorization and priming. Check them out. Our heartfelt thanks to our wonderful friends and colleagues, and thanks to the audience for your attention.